Hi everyone. Have you wondered how scientists measure the tiny distance between the atoms or the precise angle in a molecule? Understanding the molecule measurements such as atomic distances, bound distant angles, and dihedral angles is crucial for the visualizing and analyzing the chemical structures. So, in this guide, we will explore how to display and interpret these measurements in a molecular model window. Let's start this lecture. First of all, we have to draw a simple molecule to understand more. So, I have drawn the benzene for the measurement study. So, after drawing, you have to select, then go to structure, and you have to generate all bond angles. While generating the all bonds, a window will be shown. In window, you can see that there are display and atoms, which atoms are, and which is the number of atom, and what is the actual bond length and the optimum. So the first of all, we have 12 number of atoms. 6 are carbon, 6 are nitrogen. So the bond length between carbon carbon is a 1.4 angstrom, and we have again these are the okay between all carbon carbon angle length is a 1.4 angstrom, and if we measure the check the carbon to hydrogen, so let's, and the carbon to hydrogen is a 1.1 angstrom, bond length is a 1.1, is the optimal value for. So actually this is the small molecule to check, and we have if we are large molecule and other than benzene, let's create make it a nitrogen like a pyridine. We will have a different types of angles. So generate. We have generated. Okay. So let's check what actually differ. In first we have nitrogen to carbon. Its length is a 1.1. Length between nitrogen and carbon. Again, from carbon 2 to nitrogen length is at 7.4. Okay, and we have again 1.1 angle same carbon to atom. Okay, so the actual there's a no such difference that is being made in molecule. There's a no such so make another molecule, making it a more difficult to understand. So let's the NH2 and make OH this molecule and checking the bond angles. So let's measure the bond lengths. There are different bond lengths. First of all, we check the carbon to carbon, and it's 1.1, and other second 1.1 carbon, and it's also that okay. Carbon to carbon, it's a 1.4, and nitrogen to carbon, it is also 1.1. Carbon to hydrogen, it's a 1.1, and the carbon to carbon 1.4, and here carbon to carbon we have 1.4, and this is same. And if we check the, let's go to upside. Okay, this is, and this is the between the nitrogen and hydrogen, nitrogen and hydrogen distance between the nitrogen and hydrogen is a 1.0 angstrom, as lesser than uh, carbon to hydrogen. Why actually it is a less than carbon to hydrogen? Because nitrogen is a more electro negative than carbon, that pull electron toward it and make it is a more compress it. Okay, then that's why this is has a less. Angstrom, and this is the same as we have done, and this is also less than actual size of 1 point, which is a 4, but it's a less than 1, and it's a between the carbon nitrogen bond angle, and it's a 1 point actual, it's a, and optimal should be a 1.4 as I told, but it's a less than actual value. So this is the way that how can we the bond length. So let's check the bond angle, all bond angles. Okay, this window will be open, and this window shows the display and atoms which between which atoms and actual and optimal size. So let's begin from the carbon 126. Okay, and what we were checking, we were checking the bond angles. Bond angle between 1, 2, 3 carbon is a 1.18, and if we check carbon hydrogen number 9, carbon number 1 and 2, carbon number 1, 2, it's a 120 angle. Angle is a one, and which is also optimal for the sp2, as we know that, and we have it's also over 120. So the between, let's check, it's a one less than actual value, and actual value is 118, and it should be optimal for, there's a small deviation that should not be counted, but there is a small deviation. Let's check the n was less 120, and there is also deviation from the optimal sp2, and it's 118. So this is the way how can you the itself check the bond angles, and between it's a 120, and it's also 120, and this is a 16. So each of the bond angle is being displayed by this method. So you can display and visualize the bond angles, and we have another thing that is should needed to be discussed, and that is the bond dihedral. Okay, let's check the dihedral. So let's dihedral of bond. So dihedral between is a 0 between carbon number 1, 2, 6, 4. The dihedral being between the 4 carbon is a 0, and this is in a minus, and this is 79, and this is 179, and this is a very small triangle 0, it's a, and this is 180 dihedral between the carbon number 4, 5, 6, and 7. 7th is a nitrogen atom number 7, and we have the hydrogen atom number 11, atom number 5, 6, and 1, which is a dihedral angle is equal to, and we have similar dihedral angles. This is the way how can we show the dihedral each of the molecule. This is the way that how we can the, and then also another topic finally we have, that is to generate the alkylos. So how to generate the alkylos atoms? So first of all, we have to remove this. Let's remove these all first, and we can count total number of atoms. How many atoms are there? This is 63 atoms. So by clicking measurement, and we generate all kilos contacts. We have all kilos. So let's, and this is all close contacts. These are the also close one. We have another method that if you have done anything and you want to clear to finalize, this will make it a clear. There is a no display item and actual and optimal anything that you want to remove from here, you can remove from the layer. So thank you. This was all about the measurements. If you know about more things, then you can connect. Thank you.